So at the Idaho National Laboratory, we have a lot of exciting projects in the space arena. We have, of course, space battery assembly, an integration capability for the US Department of Energy and NASA. But we also have fuel fabrication capabilities that we're developing and researching for future space reactor technologies and space propulsion technologies. In addition to some of the research we're doing in the fuels arena, we have an exciting period ahead of us and starting now, restarting some heritage reactors, specifically a transient test reactor, reactor called TREAT, and this allows us to test advanced fuel concepts and fuel specimens up to very high temperatures from, in some test trains, very low temperature. So when we're thinking of space, coming up from space cold up to high temperature of operation in the 2,500, 3,000 degrees C range, and very exciting capability to bring online. This capability, the TREAT reactor, is being brought on to test current work in accident-tolerant fuels for the existing reactor fleet and Gen 3 plus, Gen 4 reactors. We're also doing some very exciting work for future applications of radioisotope and fuel fabrication technologies. We're developing a process we call spark plasma sintering. It's a field-assisted sintering technique that uses pulses of electric current that flows through the powdered materials that we essentially convert from powder into a fuel form that we can use either in radioisotope power systems or in reactor fuels. And essentially we're developing this technology to meet the specifications and rigor of qualification for flight. Once they're developed, once the process is developed, we'll be able to examine ways to implement it on the NASA RPS line at the DOE facilities. So there's a lot of exciting capabilities that will stem from some of this fundamental research. One facility we developed was a radiological spark plasma sintering facility. It was the first of its kind in the world to house an integrated glove box line with filtration to handle actinide materials. It's currently commissioned for uranium work, and we're able to essentially fabricate simulated fuel elements for nuclear thermal propulsion systems. We're able to manufacture those and develop a flow sheet that could be implemented by our industrial partners for NASA. So I think in general the Idaho National Laboratory is growing to be an internationally recognized center for excellence for space research, specifically in the realm of advanced power sources, nuclear thermal propulsion, and will grow with advanced power conversion technology research that's ongoing. It's an exciting time to be at Idaho National Lab because of the growth of some of these capabilities and rejuvenation of some other facilities. And I think for those colleagues that are concluding their university education, now is a great time to be looking at Idaho National Lab as a place to come and join and help support some of that exciting work.